Question number 25. Here we go. Let's see what it says. This guy right there, 25. All right. All it is putting it in point slope form. Right? Come on now. That's just super important. So y minus 8 equals 4 times x plus 4. That's it. All right. Yes, guys. All right, is anybody else on that page? Good.
I have a question on 29.
All right, let's look at 29. Here we go. And we said this was kind of, I'm kind of glad you asked me about that because this is something that I ask you to put in all three forms. All right, so let's go ahead and knock that out. All right, and the first thing I talked about was changing this to a fraction. All right, what did we say that was? Negative 12 over 5. So m equals negative 12 over 5.
Yeah.
All right. Now we can write it in point slope form, which would be y plus 12 equals negative 12 fifths times x minus 14. So far, so good? All right. Now again, it's kind of annoying because the numbers aren't so simple, all right? But it's still nothing too difficult. All right, so I have y plus 12. When I distribute the negative 12, it would be negative 12 fifths x plus,
180.
say it again,
180. 168.
yeah, I think that's 168, right?
Yeah.
168 over 5. And then again, we're going to subtract 12, right? Maybe that's what you were doing, giving me the final answer, right? So if I subtract 12, that's 60, right? So y is equal to negative 12 fifths x, and then it would be what? Plus, yeah, 108 over 5. Come on now, make sure you understand that. All right. So this up here was your point slope form. This right here is your slope intercept. All right, and now we just got to convert it into standard. All right, so first thing you want to do is you want to remember in standard form no fractions, right? So I just have to multiply everything through by what? 5. So you should be able to tell me 5y is equal to negative 12x plus 108. Agreed? And then x and y together. So I have 12x plus 5y equals 108. Everybody good with that?
Yeah.
Any questions? Any questions? Anybody else on this page? Like I said, super important. All right, we're going to do another unit on SATs just over lines, just to make sure you got it. Anybody else before we go ahead and get started with today? All right, so let me have those. All right, pop them out of your folder, and let me just come around and grab them real quick. All right, I'm going to pause the video for a second while I do that. Today is kind of a good day because I gave myself 2 days to go through this lesson. I don't think it's really that difficult. Our test is going to be on Tuesday, which is kind of important. So I need for you to really listen carefully. Now, the assignment for today is 2-9. So why don't you go ahead and head your paper properly for that. And then before we start on the problems, I'm going to make a few little demonstrations. All right. Now the other thing is, remember what I said about paper, guys? We're using paper all the time. I don't mind you sharing your paper with your neighbor or whatever. Remember what I said? Just call Amazon or Amazon some paper to your house. Paper's like $1 for 200 sheets. All right. Take care of business. Don't come to class without a pencil and without paper. All right. If for whatever reason you don't have a pencil, I try to keep some pencils in that green box up there. All right. Just put them back when you borrow. All right. So everybody's got their paper headed. All right. Now, if you recall in the previous section, I believe it was 2-7, it talked about what's true if you have parallel lines. And what's true if you have parallel lines? What was it? Yeah, slopes are equal. What else is true when you have two parallel lines cut by a transversal? Two parallel lines cut by a transversal. What is true? Or what was true? There was?
The angle.
Yes, what specific angles?
What did it say?
Take a shot at it.
Corresponding.
Corresponding angles are what?
Equal.
Are congruent. Very good. You're right. They're equal. All right. What else is true? Alternate interior angles were congruent. What else?
Oh. Alternate exterior.
Alternate exterior angles were congruent. And then there was one more. Very good. Very, very good. Consecutive interior angles were supplementary. All right. Now, I want you to write on your paper here. The corresponding angle is a postulate. All right. The corresponding angle postulate. That says if you have two parallel lines cut by a transversal, the corresponding angles are congruent. That is not a theorem, that is a what? Postulate. Now, how am I going to prove alternate interior angles are congruent? We're going to use what? We're going to use the corresponding angle postulate. All right, so today I'm going to prove some things. All right, we're going to prove the alternate interior angle theorem. And we're going to prove the alternate exterior angle theorem. And we're going to prove the consecutive interior angle theorem. Everybody with me on this? All right? And the only one that is a postulate is the what? Corresponding angle postulate. All right, now if you recall, I said what's strange to me when I was understanding geometry was I'm going to use a postulate to prove a what? To prove a theorem. That to me is a little weird, because what happens if our postulate is not true? Then our theorem kind of collapses. All right? So again, remember, your postulate is just based off observation. All right? So again, we will now, I'm going to go to the end here, and I'm going to prove a couple things. All right? Now down here, these are all the notes that we're going to be getting to. But I decided at the end, before we got started, to demonstrate some proofs. All right. Now, today, when I prove the alternate interior angle theorem, do I have to prove that anymore? No. You can just say alternate interior angle what? Theorem. All right. Is everybody with me on this? All right. Right now, it's hard for us to say because I haven't proven that to you yet. But now we're going to prove it. All right. So here is what we have. We have given, all right, and I'm just going to make a rough sketch of it so you can kind of do the same. If we have two lines cut by a transversal, and I call this angle 1 and angle 2, and I tell you these lines are parallel, what's true about angle 1 and angle 2? They are what? They are congruent because it's from the corresponding angle postulate. It's from the corresponding angle postulate. All right? Now, I am going to prove that angle 2 is congruent to angle 3. That's what I'm trying to do. I'm trying to prove that angle 2 is congruent to angle 3. All right? Now, what is the given? All right? Given that you have two parallel lines cut by a what? Transversal. All right? I should have written it all out for you, but all right, I was a little lazy. So this is what you have. Two parallel lines cut by a transversal. All right? Yes. Oh, hold on. Yes, you're one step ahead still. All right, so here we go. I'm now going to introduce this. Number one, all right, he's correct. But the first thing we're going to do is write down that we have, let's do this. Let's just call this L and M. All right. We can say L is parallel to M. And why is that? It's given. All right, it's given. All right, now, number two. I do want to go ahead and say what's true about angle 1 and angle 2. They're congruent. So we're going to say angle 1 is congruent to angle 2, and of course that would be what? Yes, the corresponding angle postulate. Corresponding angle postulate. All right? And I don't care if you abbreviate. All right, corresponding angle postulate. Okay, Parker, tell me what's up.
Angle 1, angle 3 are congruent.
That's correct. We would say angle 1 is congruent to angle 3, and that's what? Vertical angle. It is definitely a theorem. Vertical angle theorem. We can prove that they are congruent. All right. That's a theorem. Vertical angle theorem. All right. Is everybody good with that? Okay. So now what can I say?
Angle 2 is congruent to angle 3. And that would be substitution.
Yep, we could just do a substitution. And so we've now just proven what?
That angle 2 is congruent to angle 3.
Yes. And so we can say now what?
That
What?
angle 2 is
No, specifically. No. Yeah, well, that's going to be the converse, but right now I just want you to tell me what's 2 and 3? What is what are they called?
Alternate interior.
Yes, now we can say that angle 2 is congruent to angle 3 because of this substitution. But angle 2 and angle 3, now we can say we've just proven the alternate interior angle theorem. Does everybody agree with that? All right, now look, I'm just trying to make sure you understand me. We did not know for certain that 2 was congruent to 3. Now, we've proven that every single time you have two parallel lines cut by a transversal, the alternate interior angles are what? They are congruent. All right? So now what I want to do is I'm going to call this angle 4 down here. And we're not going to write this one out. You're just going to pay attention. All right? Now, what's true about 1 and 4?
They're congruent.
They are called what?
Alternate exterior.
Now, we know because I've told you that they are what? They are congruent, but we never proved it, or I never proved it. All right? So now, I would want everybody to recognize that proof is almost exactly the same as what? The first one. Right? So if you're looking at those numbers right there, what's true about 1 and 2 again? By what? Corresponding angle postulate. Now what's true about 2 and 4? They're congruent by what? And so now what's true about 1 and 4? They're congruent. No, by what? Substitution again. All right? Now we know that the alternate exterior angles are what? Congruent. And now that is a what? Theorem. All right? So now that we've just proven that, every time you see alternate exterior angles, you can say the alternate exterior angles are congruent by what? By a theorem. That is exactly correct. You don't have to now prove it every single time. Once you've proven it's true, it's always true. All right? So now we did the alternate interior, and we did what? Alternate exterior. And now what else do we have? No, because corresponding angle is a what? Corresponding angle is a postulate. So what's the other thing we have to do? Yeah, we have to do consecutive interior angles. All right, we have to do consecutive interior angles are what? supplementary. All right, that's what we have to do. All right, which is a little bit more challenging, but not really. All right, so I'm going to try to demonstrate that real quick. All right, so it's the same kind of thing. I want to see something real quick here. All right, so what I want to do is I'm just going to, just because for time purposes, what I'm going to do is just grab this and move this down here. All right, and now I'm going to erase this up here, and I'm going to put, let's say, a 3 right there. Okay, so now I have to prove to you, and this is, we're proving consecutive interior angles are supplementary. That's what we're doing. Consecutive interior angles are supplementary. All right, and of course the first part is going to be the same. Essentially, we have to always say that line L is parallel to M, and that again is just what? Given. And now, again, we would say, what about 1 and 2? They are congruent, so we can say angle 1 is congruent to angle 2, and of course that is the corresponding angle. Remember, corresponding angle is a postulate. Corresponding angle is a postulate. And do I care really if you accidentally write theorem down? I'm not a real big pain about that, but that's why I'm trying to say it over and over and over and over. Postulate is for corresponding angle. Everything else is a what? Theorem. All right, they could have very well just chosen alternate interior angle postulate, and then the corresponding angle would be a what? Theorem. But they had to choose one of them. So for whatever reason, they decided to choose that. All right. Now, this one's a little bit trickier because there's just something I have to remind you. What can I say about angle 1 and angle 3 form a, thank you, whoever said that, linear pair, right? Angles 1 and 3 form a linear pair. Is everybody good with that? All right. And again, we would say that that is the linear pair postulate. The linear pair postulate. 1 and 3 form a linear pair, right? Now, if it forms a linear pair, that means what's true about?
Supplementary.
Yes, very good. They're supplementary. All right. So we can say that number 4, angle 1 and angle 3 are supplementary. All right. And that is, believe it or not, the definition of linear pair. That's definition of linear pair. All right. Everybody okay with that? And now I could say that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Do you agree with that? And then that would be definition of supplementary. But I make it even easier. What's true about angle 1 and angle 2? They're congruent, so I can change angle 1 for what? Angle 1 can be changed to angle 2. So angle 2 and angle 3 are what? Supplementary. Come on. And that's by simple what?
Substitution.
Yeah, I can call substitution. All right, that's kind of an abbreviated form, but again, I want to take a look at that, and I just want you to see that's really not that hard. All right, it's really not that hard. Okay, now again, I feel like linear pair postulate, we haven't said that much. So 2 angles that are adjacent and form a line, that's what? A linear pair. All right, and adjacent just means they share a common ray. All right, does that make sense? They share a ray. All right, and then the definition of linear pair just means if you have a linear pair, that those two angles are what? Supplementary. There's nothing really I can do. This is not math, right? You can't sit in here and go, oh my gosh, that geometry is so hard. It's not. It's you have to understand the what? Definitions. You have to understand the words, all right? And if you have a gap there, it's very hard to do the proofs if you don't pay attention and you don't follow along with me. And like I said, I'm not asking you to know that. I think someone has to tell you that. And then eventually you can do it on your own, all right? And honestly, if you like this kind of thing, it's kind of weird right now, but like I tried to tell you before, that's why they're building these skyscrapers. They're not hoping they stand. What? They know they'll stand. That's why they can build these skyscrapers. All right? Because it's not something that they're just taking a chance and hoping it stays and stands up. All right? And then when there are accidents, then one of the engineers messed up. All right? One of the engineers messed up. All right? How they assembled it was incorrect. Because they've proven that it will stand. All right? And that's what's kind of neat about math. All right? You can prove everything. All right? And so now what I want to do is we're going to get back to the beginning here, and let's see how you can do with this section. All right? Now, a lot of times we say in math the converse. All right? For example, if two lines are parallel, then what? The alternate interior angles are what? Congruent. All right, now what is a converse? A converse is when you switch that order. So you would say, if the alternate interior angles are congruent, then the lines have to be parallel. That's what's considered a converse. All right, there is a hypothesis is your initial, your conclusion is your final. When you switch the hypothesis and the conclusion, we call that the converse. All right, is the converse always true? No, the converse is not always true. But in this particular case, is the converse true? If the alternate interior angles are congruent, then the lines must be what? The lines must be parallel. If the corresponding angles are congruent, then the lines must be what? So all of the converses are what? Are true. So I want to say it one more time now, just so you hear me. All right? What we've been doing so far is we've been assuming that the lines are what? Parallel. The converse assumes that the angles are congruent. If the angles are congruent, then the lines are what? Does everyone understand the difference there? All right? What we've been doing so far is we've been talking about the lines are parallel. If the lines are parallel, these four statements are true. Now I'm going to say if the four statements are true, then the lines must be what? The lines must be parallel. All right? And again, I keep trying to fuss at some of you because I need you listening. All right? Listen. All right? It's much more important to listen. And if you're not understanding what I'm saying, speak up, because I repeat it so much because I know it takes more than once. All right? Good for you. Yes, okay, so here we go. Very important. Converse, the initial statement we say is an if-then statement. If the lines are parallel, then the alternate interior angles are congruent. That's the original conditional statement. If this is true, then this is also true. You with me? In a converse, you switch the order. For example, if the angles are congruent, then the lines are what? You see the difference. The first part, we start out with the lines are parallel, and then we concluded stuff about the angles. Now we're making conclusions about the angles, and then showing that the lines are what? Parallel. You with me on that? Yeah. So the converse is just when you switch what we say the hypothesis, your statement, and your conclusion. Agreed? All right. And again, that's a good thing to ask. Converse. If you ever get stuck, write converse down, and then you have Google. You can look up converse, and it'll tell you exactly. And a lot of times, to clarify, I type in converse in geometry, and it'll tell you exactly what we're looking at. All right? So again, that's really important for today. All right? Now, let's go back to the top and see where we're at. All right, here we go. All right, lots of kind of a good proof day, but we're going to take 2 days. All right, so here's what we have to be careful with. All right, now again, I'm going to, I think it's perfectly fine looking up here. All right, making sure you're with me. And remember, guys, I'm trying to tell you, if you want to change your grade, change what you're doing in class. Don't let me get to question 10 before you start asking me a question. Understand it now. All right, that's what I'm telling some of you. All right, here we go. Now I'm going to highlight angle 1 and angle 3. If that's congruent to that, what is true? You can't say the lines are parallel because there are 4 lines up there. You have to be specific. That means what? J and K are parallel. Exactly. Now, how do I know that? Again, here's what I'm telling you. All right. I personally never had a problem seeing this, but from experience, I know some people aren't the best at visualizing. So again, I try to help those who can't see. All right. So here's what I'm saying. I kind of like draw arrows, and that's pointing to the transversal and the parallel lines. Everybody with me? Does everybody agree M is not being touched at all? Therefore, M is not part of the problem. All right? Now, I can't be any more clear than that. And believe it or not, I have kids who miss it when I put it on the test. So I'm asking right now, does everybody understand that M is not in the picture on this one? All right, so let's look at the next one. So now I have 2 and 5. So I'm going to highlight 2. Can you see that color? And 5. Again, all right, is M in the picture at all? No, so it has to be what? J is parallel to what? J is parallel to K. All right, here we go. Let's see how we're doing. All right, now we're talking about 3 and 10. So now I'm at 3 again, and I'm at 10 again. So what 2 now? Remember, I can't tap you on the shoulder and say, hey, you understand what I'm doing? Right? Does anybody have any issues with why L is parallel to M?
So the answer is just L is parallel to M?
Brilliant. That's all we're doing. Because this is just a visual thing. That's all I'm trying to say. This is nothing. This is just trying to make sure that you can see the picture properly. If you can't see the picture, the rest of the page is going to be kind of hard. All right? And let's look at 6 and 8. So again, we're talking about 6 and we're talking about 8. So here's 6 and here's 8. So again, you should be able to tell me what? L and M are parallel. All right? L and M are parallel if 6 and 8 are supplementary. Everybody feel pretty good about that? Not a big deal, right? All right. Let's see how smart we are. Let's look at number 5. Okay. So is this a postulate or a theorem that we're using on this one?
Postulate.
It said theorem. Why? That's exactly right. Alternate exterior angles. And I already said the only one that's a postulate is what? Corresponding angle postulate. So brilliant. That is a theorem. That is a theorem. All right. And specifically, it's the what? Alternate exterior angle theorem. And the alternate exterior angles are congruent. Now, I never had a problem with that because I could look at them and say they're both what type of angles? Obtuse. So if they're both obtuse, that means they are what? They're equal. If you have an obtuse and acute, they always are what? Supplementary. That's exactly correct. So in this case, we're just going to go 4x minus 23 equals 2x plus 17. And everybody, don't solve it. We're practicing our mental math. So move numbers around. Come on. Everybody should be able to look at that. I want everybody in here. You'll dazzle your math teacher next year when you can tell them what the answer is. So x is what? Tell me.
15.
15. 20.
20.
20. Yeah.
Oh, wait, 20, yeah.
Yeah, good. So x equals 20. That's what I want from everyone in here. Just write x equals 20. And if you made a mistake, generally it's the mental math that you made a mistake on. All right, does anybody have an issue with that's x equals 20? That was pretty simple, right? All right. Now my problem is I don't know what Theorem 2.20 is. All right, so we'll just see. Look up Theorem if you're in the... Yes, okay, so that's what I was trying to tell you. Okay, so now here is what some kids did on the test last year, and the year before that, and the year before that. Every year I say I'm going to try to do a better job explaining. All right, given angle 1 is congruent to angle 2, we're not allowed to just say the lines are parallel because we haven't proven the what? We haven't proven the converse. That's what we're kind of doing right now. We're proving the converse. So once we prove this, if somebody said to me angle 1 is congruent to angle 2, I'm going to say, of course it is. Because they are what? Alternate exterior angles. Do you agree with this? All right. So again, I will write specifically, you're proving a theorem. If you're proving a theorem, you can't use the theorem to say that it is what? To say that it's true. Now, I just said something important, so I want to make sure you heard me. I'm trying to prove the alternate exterior, the converse to the alternate exterior angle theorem. Does everybody agree with that? So when I prove that, all right, I'm not going to say what? Well, they're alternate exterior angles, so the lines are parallel. That's what I'm trying to prove, yes? All right, now I just said it 2 times. I'm hoping I'm clear. All right, because every year, 5 or 6 kids say they're alternate exterior angles. They're congruent. That's not what I'm doing. All right? I'm asking you to prove a what? Theorem. All right? We're asking you to prove a theorem. So here we go. Let's see what we can do on this theorem. All right? And again, what is true? 1 is congruent to 2, correct? 1 is congruent to 2. All right? And that is what? Given. So here we go. So 1 is congruent to 2. Now, why is angle 2 congruent to angle 3? Yes, we can say the vertical angle theorem. Now, do you see how they use the transitive property, right? So I want to make sure you guys are hearing me. Does it matter if you use transitive or substitution? No, but let's review transitive. If 1 is congruent to 2 and 2 is congruent to 3, then we know automatically that 1 is congruent to what? 3. If you wrote substitution, do I care? I don't really care. You should just know the transitive property as well. It's got to be set up in that order. So 1 is congruent to 3, therefore it's the transitive property. Now, what can I say? Now, what are we trying to prove? Yeah, so now we can say L is parallel to M. All right, why can we say L is parallel to M? No. Yes, the corresponding angle postulates. Now, technically, and I don't care if you write this, but I'm going to be technical with you. This is a what? It's a converse of the what? Corresponding angle postulate. Don't worry, you're always going to say it, and it's not a big deal. That's the converse. Do you agree? Because the original statement was if the lines are parallel, then what? The angles are congruent. Now we're saying if the angles are congruent, then the lines are what? Parallel. Is everybody hearing me on that converse? And on the test, if you write corresponding angle postulate, am I going to make a big deal? No, I don't really care. I'm trying to make sure you're hearing me, though. If the lines are parallel, then the angles are congruent. All right? That's the first part. Then the second part would be if the angles are congruent, then the what? Lines are parallel. So if you go from the angles to the parallel lines, that is the converse. Yes.
I have a question on C.
Okay.
Wouldn't it also be corresponding?
Actually, I'm okay with that too, right? The problem is, Emily, we were trying to establish a relationship between 1, 2, and 3. Okay, that's kind of what we were trying to do. But again, I cannot say. Let me do a better job than that explanation. Let me show you one more time. Okay, so I need someone to do a better job on my explanation. Why is it not possible? Okay, it's not possible to say 1 is congruent to 3. Why is it not possible at this moment to say 1 is congruent to 3? Tell us. Very, very smart. Very smart. Listen to what, right? If you say 1 is congruent to 3, then you're assuming that L and M are what? You with me now, right? So, yes, now that we've proved they're parallel, now we could say that 1 is congruent to 3, but we didn't know that before. All right, you can't assume that angle 1 is congruent to angle 3 because we still don't know if the lines are what? We don't know that the lines are parallel. However, we do know that angle 1 is congruent to angle 2. All right? Are they okay with that? And that is, obviously, we would say, that's the converse of the alternate exterior angle theorem, but that's what we were trying to what? That's what we're trying to prove. All right, so hopefully I'm making some sense on that. All right, I feel kind of good about that. Bless you. All right, so let's go. Let's have some more fun. All right. Yeah, how much time do we have? Yeah, 5 minutes. So here's what I want you to try to do for me tonight. Let's do 8 through 23. All right, try to fill in that proof for 8 through 23. And then tomorrow we'll go into writing some more proofs. All right, but I feel good about you should have no trouble with 8 through 23. All right, everybody good with that? And then tomorrow we're going to finish the section, which brings us to Friday. We'll review. Monday we'll review. Tuesday's the test. What? Oh, yeah. No, I'm never a fan of that. All right, thank you for reminding me. 22 is no, I don't like that. All right, just do the problems. All right, not 22. Everybody good? All right, good job today, guys. Very good.